In this video, we'll discuss the causes and effects of earthquakes. Let's begin. How exactly does an earthquake occur? Well, to understand this, we've got to understand the structure of the surface of the Earth. The surface of the Earth is made up of multiple plates. These plates are curved and they're called tectonic plates. Now, you can think of these tectonic plates as, say, a broken eggshell, but put together, right? Together, they form the surface of the Earth. Now, these tectonic plates meet each other along a line, right? Sometimes these lines are under the ocean, and at times they're on land, and at times they can look like this, where this is tectonic plate 1, this is the second plate, and in between runs this joining line called the fault line, right? When these plates slip and slide over each other, we have earthquakes. Let's discuss the slipping and sliding in a little more detail. So let's say this is tectonic plate 1, this is plate 2, and let's say this is that line along which the slipping is happening, right? And these plates are slipping and sliding over each other, causing a jolt to the surface of the Earth, causing an earthquake, right? And if you look a little more carefully, you'll notice that the slipping and sliding is happening not just at a line, but over an entire plane. That entire plane is called the fault plane, right? So the fault line is only the visible line on the surface of the Earth, right, of the entire fault plane. Okay, now the fault plane need not look exactly like this everywhere. It looks differently. I'll show you a few examples. So fault lines and fault planes could look something like this. Here we have the fault plane vertical, right? And we have the sliding side by side, not on top of each other, right? In this case, it's similar to the first case that we were discussing. The fault line and fault plane look similar, but this tectonic plate is going over and above the next one, right? And these three are not the only ways in which slipping and sliding happens. It can happen in multiple other ways too. These are just some examples. Now, when the slipping and sliding happens, a disturbance is generated, right? And that travels and causes the earthquake. Let's see how this disturbance travels. So let's say this is the ground and this is the sky, and we have a bunch of things on the ground, right? And this is a 2D view of the entire story, a cross-sectional view. And this is the side view of our fault plane, right? Okay, now let's say at some point under the Earth's surface along the fault plane, there's some brushing of rocks and some kind of activity between these two tectonic plates, right? And that will cause a disturbance to start propagating in every direction, right? This disturbance travels as a wave. Now, two things I'd like to tell you. It's not always that the entire tectonic plate is going over and above the other one. At times, this disturbance can be created by some kind of tectonic activity, some kind of, clashing of rocks together, which is under the surface of the Earth, right? And that causes this disturbance wave to travel in every direction. Okay, so the point where the wave starts is called the focus. Let me write that down. Okay, and the point that's right above the focus, directly vertically above, is called the epicenter. Now, the epicenter is a point on the surface of the Earth, right? You can give it an address. Okay, let me write that down as well. The epicenter is also the place where maximum destruction tends to happen, right? Okay, now let's get to discussing how we record these earthquakes. Now, these earthquakes are recorded using something called a seismograph. The seismograph records vibrations, it records disturbances. Whenever there are larger disturbances, you can see those on this piece of paper, right? So that is an abnormally large disturbance. Could be an earthquake, right? Now, this was just an animation. Let me show you how an analog seismograph looks like. This is how an analog seismograph looks like. There's a roll of paper and there's a needle there. Let me zoom in and show it to you. There you go. So this needle is recording all the vibrations. At times these vibrations are small. At times they could be large like this. Right. Now, I'm not telling you with certainty that this is an earthquake. Why? Because these analog seismographs need to be kept in a very, isolated place, in a place where people are not walking around, because these are very sensitive. If I tapped on the table, that would create such large vibrations to be recorded. So at times people, keep them out in museums to show you how these seismographs work. These days we have more advanced seismographs that are digital and have a much better noise filtering mechanism that can filter out all the noise and pick up only the important data. Okay, now let's list out a few causes of earthquakes. Volcanoes are a major cause of earthquakes. So if there's a volcano that starts, erupting, there can be some kind of activity below the surface of the earth with the magma and stuff, which can cause the tectonic plates to get unsettled and cause an earthquake. Volcanoes are natural, but the next reason we're going to discuss is dams. Dams are a man-made cause of earthquakes. Now, let me explain how a dam can cause an earthquake. So this is our wall for the dam, which is holding up a huge amount of water, right? To be able to hold up such a huge amount of water, the dam has to be anchored very well. It has to have a very deep foundation on the earth's crust, right? Okay. Now, all of this water is applying a lot of force on the wall, and that force is going to be transferred to the tectonic plate on which the wall is built. Think about it. That can cause some kind of slipping to happen, right? And that would cause an earthquake. So mega dams, which are, holding up a huge amount of water, can cause earthquakes. Micro dams, small ones, the small ones built in small villages, don't really cause much issue. Okay, mining is another man-made reason for earthquakes. When excessive mining is done in sensitive areas close to fault lines, that can cause earthquakes too. Atomic testing. This is another reason of how we cause earthquakes. An atomic bomb sends huge disturbances into the neighboring region, right, surrounding region, and that can cause earthquakes. Let's go to our last reason. This is a reason which is a natural reason. When there's some kind of activity in the inner layers of the earth, that can get transported to the outer layer, the crust, and cause some unsettling vibrations which can cause earthquakes. Okay, what are the effects of earthquakes? Loss of life and property is the biggest problem with earthquakes. Very often people lose their lives because they're stuck inside a building or a tree falls on them or some kind of destruction due to an earthquake causes them to lose their life. Earthquakes also cause a lot of loss of property. Many buildings are broken down, roads are broken down, airports may be broken down, factories are broken down, and that causes financial loss too. The other issue with earthquakes is fires. Very often when a building collapses, the electricals in the building get short circuited, causing a fire. And that can cause more damage in addition to the already destroyed building, right? And fires can take lives too. Sometimes it's not just the earthquake that takes the life, the fire caused by the earthquake can kill people too, right? Tsunamis are another very deadly thing caused by earthquakes. When there's an earthquake at the bed of the ocean floor, that can trigger a huge wave to be formed, and that wave can destroy coastal areas. Earthquakes can cause issues with the water table too. If there's one portion of the surface of the earth which is, moved due to some tectonic plate activity, the groundwater table can get disturbed. And that can cause changes in the water level, can cause contamination in the water level, and other such issues. Okay, let's discuss the last effect of earthquakes, and that is destruction of ecosystems. Very often, when an earthquake happens in a place which has a large amount of trees, those trees fall down. And that destroys the habitat of a bunch of organisms. And hence the entire ecosystem gets affected. Let's summarize what we studied in this video. How does an earthquake occur? Well, we discussed that it happens due to the sliding of tectonic plates, right? We discussed that along the fault line, there's one point where seismic activity originates. That point is called the focus. We discussed that the point right above the focus on the surface of the earth is called the epicenter. And the epicenter is where there's a tendency for maximum damage. Great. We also listed out a few causes for tectonic plate activity, and we discussed a few effects of earthquakes. If you want, you can take a screenshot of this video. It will capture pretty much the essence of the video. Thanks for watching.